Next question, 3.14. The Earth's surface has a negative surface charge density 10 to the power of minus 9 coulomb per meter squared. The potential difference of 400 kilovolt between the top of the atmosphere and the surface results due to low conductivity of the lower atmosphere in a current of only 1800 ampere over the entire globe. If there were no mechanisms of sustaining atmospheric electric field, how much time roughly would be required to neutralize the Earth's surface? This never happens in practice because there is a mechanism to replenish electric charges, namely the continual thunderstorms and lightning in different parts of the globe. Radius of the Earth given 6.37 10 to the power of 6 meters. So, the Earth has got negative charge. It has to be neutralized. Positive charges come from some height to the entire globe of the Earth. Current being 1800 ampere. So, how much time it will take to neutralize the entire charge on the Earth? Of course, he has given the explanation. It is not practically possible, but assuming it is possible, how much time will it take? So, what is the idea? Earth has got negative charges. According to textbook, he has given there is a potential difference of 400 kilovolt. So, there is a potential difference 400 kilovolt top of the atmosphere and the surface of the Earth. That results in a current of 1800 ampere. So, according to the question, Earth has got a negative charge. Positive charges come from say some height because there is a potential difference of 400 kilovolt which results in a current of 1800 ampere. How long will it take to neutralize the entire Earth, charge on the Earth? So, first negative charge on the Earth, how much is there on the Earth? So much positive charge should flow. Thereby you can neutralize the Earth. Okay? So, here what you should do, I is Q by T. T is required. Q by I. I is given 1800 ampere. Q is 4 pi r squared sigma by I. That's all. R given radius of the Earth. Sigma given surface density. I given 1800 ampere. Simply substitute. Maybe you will not use this 400 kilovolt. Okay, 400 kilovolt. 4 pi r squared 6.37 10 to the power of 6 sigma 10 to the power of minus 9 current 1800 ampere. This on simplification will give you 283 seconds. So, the answer for this question is 283 seconds. Okay. Next question, question 3.15 or question 3.15. Subdivision A, 6 lead acid type of secondary cells, each of EMF 2 volt, internal resistance 0.015 ohm are joined in series to provide a supply to a resistance of 8.5 ohm. What are the current drawn from the supply and its terminal voltage? Subdivision B, a secondary cell after a long use has an EMF 1.9 volt and a large internal resistance of 380 ohm. What maximum current can be drawn from the cell? Could the cell drive the starting motor of a car? So, first part, 6 cells, secondary cells. So, each one is having an EMF 2 volt, internal resistance 0.015 ohm, all identical. External resistance 8.5 ohm. Suppose to find current and terminal PD. Okay, let's say you use KVL for this 8.5 I is the current, let's say 8.5 I plus same current I goes there. So I into 6 such cells are there. So 6 into 0.015. IR R is 0.015. 6 such R. So 6 times 0.015 the current I. Minus the EMF of the battery should be considered now. Go from negative to positive of the cell. So you take them to be negative. One way of using the convention. So 6 is there. So minus 12 is 0. So supposed to find I. Okay. So 8.5 I plus this 12 will go to the other side. 0.09 I. Okay, 8.5. Therefore, I is equal to 8.59. 12 by 8.59. That is a current. This will be 1.39 ampere. So you write 1.4 ampere current. Terminal PD means PD across this, which will be same as PD across this. So terminal PD, that is also asked, 1.4 into this 8.5. 1.4 into the 8.5. You can multiply directly, or what you can do, make it 17 by 2. That 2 with this 0.7 into 17. If you can directly multiply, you can multiply. Or 8.5 you write as 17 by 2. The 2 you can do with this 0.7 into 17. So 11.9 volt. So terminal PD is 11.9 volt. First part is over. Now go to second part of the question. That is second subdivision of the question. This is the answer. Current is 1.4 ampere. Terminal PD 11.9 volt. Okay. So now we go to the second subdivision. So I is E by R. So 1.9 divided by 380. That will be the large current which is possible. Okay. This will be around 5 milliampere. Because 119 and 380 is there, no? So you can write this as 1.9 by 3.8 into 1 by 10 power 2. This will be 2. This will be 0.5. 0.5 into 10 power minus 2, which is 5 milliampere. So the current is very small. It cannot start a motor, because for that you need a very large current as large as 100 ampere, but you are getting only 5 milliampere here. So we can't use it to start a car. Okay. Thank you.